Hello, everyone. I'm Rami Aluta. I'm a solutions engineer working with Esri out of our Rotterdam's office. I do support global nonprofit organizations and land administration organizations. I've been working with Esri for the past 5 years, and previously to my job in Rotterdam, I've worked as a platform engineer out of the Dubai office supporting professional services. Today, I'd like to welcome you to our GeoAI workshop, where we will be discussing different workflows and advancement in the GeoAI field. We're going to be having a brief look on the different tools that come with ArcGIS Pro, along with some demonstration on how to apply deep learning tools in your daily workflows. We're going to be having a look on different available data sets and deep learning models that you can download and use through our Living Atlas. I'll hope that you'll enjoy this presentation and looking forward for all of your questions. So, deep learning in ArcGIS. As you might all know, deep learning is one of the hottest topics in the tech world. There's endless fields that we can deploy deep learning in, and one of them is ArcGIS or GIS in general. There's a lot of scenarios where we might not know that we need deep learning or deep learning can help us in figuring out things in a faster way, in a more efficient way. And the aim of this presentation is to try to tackle these, to try to expose you to the different fields that we can implement deep learning in the ArcGIS platform. In the presentation today, I'm going to be walking you through the different models, through the different capabilities of deep learning within the ArcGIS platform. To start, we're going to learn what can GeoAI do for you, or how can GeoAI help. In a nutshell, GeoAI will help you predict, will help you answer questions that you don't have answers for, or the answers that you might have might take a little while to come up with. For instance, on object and feature detection. We all can detect things through images. Conventional ways we used to digitize features. We used to use raster analytics and rasters processing in order to come up with results. And these might take a long time. Now, with object and feature detection, this is made easy. With feature detection, you can detect anything that you can think of as long as you can see it and spot it in the image. We can do cars, count cars in a parking spot, or count buildings in a city. We can count livestock and we can count trees. You name it. It's endless and there's tons of different things that we can detect. We're going to be going into the details of that as we go through the presentation. Clustering. There's a lot of data that is fed every day. We are getting enormous and gigantic data sets that most of the time we can't understand or interpret. With clustering and with prediction, we can know and have insights about movements, about hotspots. For instance, with COVID, all of the COVID points that we're getting, all of the reports of cases, all of these can be figured out and we can know where are the hotspots, which is actually being done as we speak. Or traffic. Each city on the planet is having a problem at one point with traffic, with congestion, and we want to understand the patterns of these. Deep learning will enable you to do that. Land classification is another important subject. We've spent a lot of time trying to create maps, land classification maps, those that cover the land cover or land use of a certain area. Me as a landscape architect, I've spent endless hours trying to build maps that represent my site, that have the land cover of my site, and gathering that data wasn't that easy most of the time. Now, with the available imagery services that are available for the public, either with Sentinel or with Landsat, or even with satellite imagery, high-res satellite imagery, drone imagery, drones that you've got, your mobile phone, all of that are sources of data that we can get in and do different detection and different patterns on. And land classification is one of these. Anomaly detection, that's another thing. We might have huge data sets and we want to figure out where are the issues or what is something wrong in my data set or what's an outlier in my data set. And deep learning will help us predict that. So deep learning in ArcGIS, there's different data types within ArcGIS, and most of you are familiar with it. I'll start with those because they can feed into the integration and we can understand how we can use different libraries, and it can feed into the different types and tasks of deep learning that we can do. ArcGIS platform supports all of these data types that you see. Text data, we deal with unstructured data on day-to-day basis. We can get enormous text files that we can't really read, and the machine will help us read and geolocate things in or places in these texts. Point cloud is made available more and more every day. We're seeing more LiDAR data sets. We're seeing point cloud coming to our phones and LiDAR being captured by camera phones. All of these is just enormous data sets that are going into our day-to-day jobs, and we might really want to use deep learning to do that. We'll get to how to do that later on in the demos, but it's good to know that point cloud is one data type that we can use. Satellite imagery, we're all familiar with that, and there's different available models to do it. LiDAR data, bathymetric data, oriented imagery, motion imagery, all of these are just data types that you'd like to get more insights from. You'd like to understand what's going on in this data set, and deep learning will make that available. Now, when we say deep learning, it's not only dependent on ArcGIS Pro or on ArcGIS as a system. It's more dependent on all of the different components and the libraries that will enable your deep learning capabilities. So deep learning will happen on the GPU, and we'll touch that in a bit. And the GPU needs some libraries to, or the models need some libraries to communicate with the GPU. So we integrate our deep learning tools with the fast AI libraries, with PyTorch libraries, so on and so forth. And then all of this will come into different tasks, different jobs that we're going to do with deep learning. We already touched a little bit on object detection. We might want to do object classification. So I'm interested in buildings and in huts, for instance. I want to see informal settlements and normal building footprints. This is doable through object classification, as it includes object detection on top of pixel classification, which is the next subject. Pixel classification is a very handy tool when we come to discovering land cover or classifying lands. Tracking, instance segmentation, point cloud to do electricity lines inspection, so on and so forth. So there's a lot of different tasks that you can use with deep learning, and our aim in this presentation is to introduce you to these tasks and to make them available for you to use within your workflows. So let's start with a bigger image. There's the solutions. We're all interested in the solution. Those are the products that talk to our public, that target our users or our stakeholders. Some of them might be 3D base maps as a solution. And to come up with a 3D base map, there's a lot of layers that are below, and deep learning is one of them. Then ArcGIS tools and product features. And I'm going from the bigger image to the smaller one. So improve deep learning tools in ArcGIS Pro, and we're going to see a lot of these geoprocessing tools are in there to guide you and help you through your day-to-day deep learning workflows. There's ready-to-use AI model. The tools will need AI models or deep learning models or deep learning packages. You're going to hear these names more and more, and it's good to get familiar with them. So there's ready-to-use GeoAI models, and we're going to see these through our Living Atlas. Then there's some models that don't exist, or you might need to train something on your own, and that's where we're going to use the tools to train our own deep learning models. Then there's the ArcGIS API for Python, which is not only for deep learning. The ArcGIS API for Python is also a tool that will combine all the other tools that come with the Python API. So you might do inferencing, and then you might take the features and append them to a production data set after you do the QA/QC. And all of that is made available with the ArcGIS API for Python. But then in the ArcGIS API for Python, we've got the smaller component or the smaller class, which is ArcGIS Learn. And within that, there's the different deep learning models, there's the available trained models, and there's the models that are backbone of certain models. So for instance, RCNN mask, it's a pre-trained model to do pixel detection or classification in general. But you're going to train that model more, and you're not going to start from scratch. Yeah, you can also start completely from scratch and train from scratch on whatever the data type is that you're using. So to dig a little bit deeper in the ArcGIS Learn, we've got these different classes or these different data types that we can work with. And we've already discussed them. 3D point cloud got a certain model, scanned maps, time series, data preps, tabular data. All of these are different classes and different capabilities that come within the ArcGIS Learn. Talking about that, I guess we're ready to figure out that AI isn't in one place, and that's what we're trying to say. It doesn't sit only in your ArcGIS Pro or in one product within Esri. It's not one product that we call GeoAI. GeoAI or AI, it spans across the ArcGIS system. And there's all of these different apps that you can actually work with. So ArcGIS API for Python, we mentioned that. ArcGIS Velocity to visualize real-time and to get real-time data, it's there. Notebooks where you can deploy ArcGIS API for Python. Certainly ArcGIS Pro for all of these desktop users, the tech savvies that they just want to use desktop and do the complicated, complex ArcGIS analysis, spatial analysis that's made through ArcGIS Pro. ArcGIS Online and Enterprise will also enable you because they work hand in hand with the Python API and it's there as a tool for you. And then all the others. So the GeoAI in general is growing across the ArcGIS system, and you're going to be able to tap onto it in whatever product that you're using in a way or another, which gets us to the bigger image. So deep learning workflows in ArcGIS. I do like to believe that it is an end-to-end workflow from raw imagery to a product that can talk to the stakeholder, that can communicate the idea. Most of the people aren't interested in how you did it through deep learning or the details of what's happening in the back end. They're interested in seeing the results in a fast, efficient way. And within the ArcGIS system, we can do that. So we got our normal images through, assuming we're working on an imagery example. We're going to get our images through a satellite, through a service, through a drone, you name it. And then you're going to label these. Most of the time, you do have your labels, and sometimes you do have to create your own. So it's a combination of both. Once you finish labeling your features, for instance, labeling that this is a building or labeling that this is a tree through the normal convention tools, you're going to go and do data prep, and this is made available through the tools. Once you export your data through code or through the GP tools within ArcGIS Pro, the data is going to be ready through a certain format that you predefine, and you're going to go to the next step, which is train your model. And training the model is as simple as it is, as complex as it can be. We need to understand what are we trying to detect. What is the model I'm interested in? And if I'm only interested in count, then I don't want to really go to pixel classification. And we'll talk about that in a bit. I might just want to focus on object detection. And I want to say that this is a cow, for instance, and this is a goat if I'm doing livestock. And these are examples that were done before. Or this is a palm tree and this is an apple tree. And I just want the counts so that is doable. Inferencing is the third step. So I got my model trained, I did all the job, and I'm pretty confident of the results that I'm gonna get. Inferencing comes there, and I detect whatever I'm trying to get out of my imagery or raw data. Now, one thing that I want to mention before moving the analysis is the labeling to inferencing process. It's an iterative process. So it's not always the model reaches a place where it's fully capable of detecting anything. There's always change in the type of imagery, in the shape of things. And I want to always make sure that my model is retrained and retrained to do so. And in one of the demos later on, we will see how to retrain a model through ArcGIS Pro. So moving forward, we finished our inferencing process, and now we're at our QA/QC process that will take us to the analysis. With QA/QC, we're more interested in figuring out what will pass and what will not pass as detected objects or classified objects. With the QA/QC process, for instance, if we're dealing with buildings, we might need to remove the buildings that aren't actually buildings in my map. To do so, I can overlay the data with my roads, with my parcels, and just get more insight of what is actually happening in real life. So the spatial analysis tools will enable you to do that process. And then we're done from that. We're good to go. And we want to do analysis. We're going to do real ArcGIS analysis. So for instance, I'm detecting trees or agriculture in general, and I was able to come up with that. Now I want to figure out the hotspots of agriculture in the area I'm studying. How are the trends? When are the seasons? How is the change happening? And all of that is made available through the ArcGIS Pro analysis tools or the ArcGIS online analysis tools or any analysis tools within the ArcGIS system. Now, when that is done, it's time to move forward. Time to tell my story and showcase it. And that is with the different cut apps that come in the ArcGIS system. We're talking about dashboards, we're talking about workforce, we're talking about story maps. So all of these are tools that are made available for you to showcase your work, to produce readable work that can talk to your stakeholders and to the public. So let's dig deeper into deep learning. Let's start about talking about the different models and the different workflows that you can do. So with object classification, you're just interested if this is X or Y, this is happening because of this reason or that reason. So for instance, what you're seeing in the image is damaged buildings and undamaged buildings. And I can get a model, a feature classifier model within ArcGIS Pro that will make that easy for me. I can do it on damaged buildings, as I mentioned. I can do it on green pools or clean pools, as you're seeing. I can do it on land use. I can do it on tree types. I can do it on any feature that I might classify to more than one type. Road, is it dirt road? Is it a paved road? So all of these are examples that you can actually do with object classification within the ArcGIS system. Then pixel classification. And this is the best example for me when it comes to land cover, because I can always relate to that as a landscape architect. Land cover is one of the very complex layers that I couldn't find before, especially in countries where mapping agencies don't provide these. Now this is available. I can just grab the model and do the analysis. And when I talk about the model, we've got models on UNet classifier, we've got Deep Lab, we've got PSPNet classifier. Those are all backbone models in deep learning. And what you need to know, in case you're not into the details of deep learning, the most available are UNet classifier models, and they're made available for you either to train or to just get and use through Living Atlas and through the ArcGIS products, or as ArcGIS Pro or as online and enterprise. And the application of that, as I mentioned, can be as land cover classification. I'm interested in knowing which is residential or which is urban, which is sparse, which is bare agriculture, which is forest, so on and so forth. Pervious compared to impervious mapping. So by that, there's a lot of clients or a lot of users that are interested in classifying pervious lands versus impervious to detect if someone is building more than they should be, for instance, on a parcel, and that is done through the pixel classifier. Building footprint extraction, for instance. A lot of mapping agencies are interested in extracting buildings. A lot of organizations, non-profit organizations, are interested in mapping where like countries around the world that weren't mapped before, or buildings that just we don't have data for. So building footprint extraction will enable that. Cloud detection, road detection, you name it. There's endless stuff that we can detect through the image. And again, I'd always like to repeat that whatever I can see through the image, I can detect and I can teach the model to go and find it in other imagery. Object detection. So we mentioned that, and I'd like to really say that object detection is the simplest form of deep learning in a way or another. What I mean by that is, as I mentioned earlier on, when it comes to object detection, I'm more interested in counts. I'm counting feeds in a video. I'm counting cracks on the road in a video. I'm counting light poles. I'm counting trees. So I'm not interested in the type as more as I'm interested in the count. And for that, our most famous model is based on single shot detector. Applications of that, I've been mentioning it, and I can say it again, endless. Trees, cars, airplanes, boats, shipwrecks, uh, anything out there that you can count is made available through object detection. One thing to mention, it's not only 2D view, it can be 3D view. You can count windows, you can count doors, you can count balconies through a 3D scene view. There's endless application forms. And I'd like you to take this and figure out what you're interested in counting so we can work together to make these true. Point cloud classification. This is one new application to a certain extent. It only started popping in the last year. It's made available more publicly. You can see our point cloud classification model in the Living Atlas models, and there's a link for that later in the presentation. With point cloud classification, there's also a lot of new potential for our day-to-day work. We can use it to classify electricity and utility lines, and these will help us detect where is a problem or where there's an issue that we need to report. So with point cloud classification, with utilizing point cloud data, we are able to push deep learning to new frontiers and pick up new stuff that we want to detect and make sure we highlight problems as soon as we can, because some of these might be life dependent and might cause a lot of issues later on. So moving away a little bit from the methodology and the different models that we can use in deep learning, I want to talk a little bit about where we offer machine learning and how is it in the platform or in the ArcGIS platform. So we've mentioned the Python API, and within the Python API, ArcGIS Learn comes as a model. And then there's the different ready-to-use AI models. So the ready-to-use AI models can be found within our Living Atlas, and they're always updated. They're always the same models being retrained and published again, and new models are being introduced. So always stay tuned. And we're going to see different ways to grab these models through your browser or through your different ArcGIS applications, either notebooks or ArcGIS Pro. So imagery deep learning tools in ArcGIS Pro. I'd like to say that this is the sweetest spot and the UI GUID spot where people can go and just click and implement deep learning. Because 3-4 years ago, deep learning was a capability that only developers can implement. Right now, that's not the case. You've got tools, geoprocessing tools that most of you are familiar with that you can use to walk through a full end-to-end deep learning workflow. You can train, you can export data, and you can inference. These are made available under our image analyst tools under the deep learning section. And you can do object detection, you can do pixel classification, you can do all of these within the out-of-the-box tools. I've been talking about this for a while, and I know that most of you would like to utilize these and test with them, so please do. In the QR code you see here, if you scan it, it will take you to our Living Atlas page where you can find all of these models and much more that are made ready for you to go and use it within your deep learning workflows. Building footprint has been tested. A lot of people are interested in using that. I'd like to tell you that that model works pretty good on up to 30 centimeter imagery and even sometimes 50 centimeter imagery, and it will get you good results. It will get you the results that you're looking for, and you'll find that the building extraction process is much faster than the conventional ways. Land cover classification, that's also a very interesting model that is made available, and you can use it with the Landsat data. There's the windows and door extraction, which is newly introduced, power line classification, 3-point classification, so on and so forth. Then I'd like to also share with you some deep learning resources. So Esri continues to provide support and resources for deep learning. There's our documentation site. So on our Python API documentation, you can find section there for ArcGIS Learn. You can find notebook samples. There's Learn Lessons. There's always updates on different blog posts, and these are a couple of couple of blog posts to get you started. So there's the Deep Learning with ArcGIS Pro Tips and Tricks, Part 1 and Part 2, and more are coming in there. Those will walk you through step by step into deploying your ArcGIS framework or deep learning framework within ArcGIS Pro, making sure that you've got the right GPU, making sure that everything is ready for deep learning process. And then the second one will walk you through the different steps in order to use out-of-the-box models. Then there's the pre-trained models, which are explained well in these two blog posts, and they're made available for you to use. At this point, we're ready to move into our demos and see some action on how to use deep learning within the ArcGIS system. So please enjoy and let me know if you've got any questions. So our first workflow for today is detecting windows and using deep learning for that. To do so, we're going to add a scene layer for San Diego. As you can see, this is a 3D scene layer that represents the building of San Diego. I'm going to zoom to my bookmark and check the Windows view that is out there. I'm going to go into my Analysis tab and click Exploratory Analysis and Object Detection. In the Object Detection, I first have to pick up my model. I'll go to Living Atlas, type the LPK, and search for the models. In there, I do see the Windows and Door Extraction model. I'm gonna do cancel because I've got it downloaded. I'm gonna pick Windows, enable GPU, and rename my output feature layer to be Demo or Windows San Diego Demo. And then what I'm gonna do is pick up horizontal bounding boxes. You can do different symbology types and pick Apply. When I do apply, the tool will run and it will take seconds till I see that the tool actually detected all the windows that I'm looking for. You can see these on the screen. I'm going to pan around and you can see that the windows that were in my view were easily detected out of the box with an available Windows deep learning model. My next workflow is going to be on land classification. As I mentioned, I'm pretty enthusiastic about land classification and I like doing land classification detection. For that, I'm going to use publicly available datasets and layers. I'm going to my Living Atlas and I'm going to search for my Sentinel dataset. I'm going to add the Sentinel-2 views to my imagery and it will load on the global scale. One thing for the deep learning model, you need to create a processing extent or disable the processing extent to none. So I'm going to copy my Sentinel, leave one with the RGB or natural colors, and make one with all the templates or the bands that are in there. So no processing template. To do so, I'm going to go to the processing template under properties and go down to none and click OK. This will make sure that the model will run smoothly. The next thing I'm going to do is zoom to my bookmark because I want to do my deep learning detection on a smaller area rather than the planet because that will use a lot of GPU and take a long time. I'm going to go to my geoprocessing tools and search for classified pixels using deep learning. This is a tool under Image Analyst. For the first variable, I'm going to drag the no processing template raster, and I'm going to rename my output classified raster. Then I'm going to go to my model definition, and for that, I'm going to use, again, a Living Atlas model definition. So the same workflow as before, go to Living Atlas and type DLPK. Pick up the land cover classification for Sentinel-2 and click OK. The model will take a little bit to load because it's being extracted. And then I'm going to change the batch size to 16 because I do have an RTX 5000 with 16 GB RAM. So that supports a higher batch size. And I'm going to go to my task manager and show you how to monitor the GPU, what's happening when I run the tool, because the tool will run over the GPU To do so, I'm gonna need to do one more thing, which is the extent. That's my current display extent. And in the processor type, I'll pick GPU. And the ID of the GPU is 0. It's good to know your GPU ID because the task manager might be not good information to pick up that. So to do so, you'll have to go to command prompt and type NVIDIA SMI and pick up the ID there. That's the ID of the GPU, and it's 0 in my case. In case NVIDIA SMI doesn't work, you'll have to install the CUDA toolkit, which is there in the documentation of installing deep learning frameworks. I'm going to run the tool, which will classify the pixels of the image. And as you can see, I can see some movement on my CUDA. So the GPU is being utilized and the memory is being utilized. This will take a little bit of time and you will see the results in a moment. I can do land cover classification in a matter of no effort and no time, available with deep learning models out of the living atlas. So you don't even need to worry neither about the model nor about the imagery. And you can see the tool is done. I've got a land cover classification with all of the classes that you see in my table of content. And this is pretty accurate for my analysis, where if I go and use the swipe tool, I'm able to go over these and detect that, yeah, this makes sense. My urban settlements are urban areas or urban fabric, and then the pasture lands and the arable lands are there. With this, we're ready to move to the next workflow, which is building detection. And that's another really interesting one. For this, I'm going to be using data from Lantmäteriet Sweden. They provided me with 15 centimeter imagery. I added that to my map, and you can see that if I go to the source and the raster information, the image is there. It's 16 centimeter to be more accurate. I'll zoom in and show the details. And as you can see, this is pretty high-res imagery. Gonna zoom into the full extent. And then what I'm gonna do is go to my geoprocessing tools again and type detect objects for you using deep learning. My input raster will be there. I'll rename the output to be able to locate it in my DB. And then the next step, I'm gonna get a model definition from Living Atlas again. So DLPK, and now I'm gonna pick up the building footprint extraction. Again, this model works on up to 50 centimeter imagery, though the better result is on 30 and below. The next step is to define my batch size. So I'm gonna do the same as before and define a 16 batch size since my GPU can handle that. And I'm gonna click non-maximum suppression to make sure that the buildings detected that overlap over different iterations are merged. Finally, I'm gonna use my GPU and run the tool. The tool will also take some time. And in the meantime, I'd like to discuss what is happening. So the first thing is I want to monitor my GPU. And if I go to my GPU, I'll see that if I enable CUDA, there's actually an activity happening on my CUDA and my RAM is being utilized, which is good signs. The process is working as it should. So the tool is right now picking the images and it's doing the image chip size, which is different images, dividing this whole aerial imagery to small batches and looking into each small chip for buildings and detecting them. That's how the deep learning tools work. So after detecting all of these features, it will merge them and will create a one building feature class that I can use and I can see my data in. And the data should be coming in a matter of seconds. And here it is in our table of content. There's a newly created feature class that reflects the building. I'm changing the symbology so you can see the buildings in a better view. And as I zoom in, you can see the accuracy of these detected buildings. They're pretty impressive and they're almost ready to be used for production. With minimal QA/QC process, I can assure you that I detect each and every single building in my extent and I'm delivering results as needed. Our next step is with bare agriculture lands. I'm going to add a training sample with the bare agriculture land and Sentinel imagery that I exported. In the training sample, you can see my type and class. And what I'm going to do is first export data for deep learning. To do that, I need a bounding geometry of my training data. I'll use minimum bounding geometry, add my demo training sample, and edit the output feature class. The bounding geometry will help me export training data for deep learning. I'll choose rectangle by area and I'll combine or group all the features. The result would be a bounding box along my training sample. Note that the training sample isn't a full one and I'm just showing how to do the workflow. Export training data for deep learning will happen with our input raster, which have the images, and then the output folder for my training data, which will be a local folder that the chips will be exported to. I will then add my feature class for the training sample and the bounding geometry that I just created. Note that the class value is class and the tile size is something that I need to watch for. Because if I'm doing training data for the purpose of retraining, I need to make sure that the chip size is the same as my model. So if I go to my existing model and examine my EMD folder or file, I'll be able to pick up some valuable information from there. For instance, the image height and the backbone of the model. So the chip size is the same as my existing model, 128, 128. And usually for stride, I make sure to maintain the overlap. It's half of it, which is 64. Then for my metadata, I want RCNN mask because that is the backbone, ResNet, which is RCNN mask. And I'm ready to export. I'll run the tool, and this will export my training chips into the local folder. The next step is training my model on top of the exported training data. So I'll go for training deep learning model, and I'll locate my existing or the file that I just exported with the training data. As this loads in, I'm going to specify an output path for my model, which I'm going to use for inferencing later on in the workflow. Specify the bare agriculture model name, and I'm going to put the epochs or the max iterations of the model to 40. The model type is mask RCNN, and the batch size is 12 in this case, because as I mentioned earlier, I've got a GPU that supports that. For pre-training model, I'm going to pick up an existing bare agriculture model that I pre-trained. And for my environments, I need to make sure that my GPU is right. So I'll pick up the GPU processor type and I'll run the model. The training might take some time since I'm doing this for a demo. I'm not gonna go into a long process of retraining and it's just for the sake of showing you how to do it. But this is a lot of iterations, as I mentioned in the presentation, and we need to do it again and again in order to reach a satisfactory result. You can see that the model is training and it's going over one epoch after the other. The validation losses and the train losses will tell us how the things are going. Eventually, what you want to reach, and when you know that you have certain confidence in your model, is when you see that the training loss is bigger than the validation loss, which needs some time to be There, you need to retrain and keep adding more training samples into your data sets so it builds up and you reach a place where you're confident about your model. As the model goes from one epoch to the other, you'll see that the numbers are changing and they're getting closer. Eventually, at one point, you will reach a place where your training is a little bit higher than the validation, and that's where you're confident about the model that you're training. Also note that this is a process that will consume a lot of computing power from your GPU. So you can see that I've reached an accuracy of 0.54, which is considered low, and I still need to train more. But with this, you've seen how to retrain a model on an existing model, and you can apply the same workflow to any process that you're running when it comes to training deep learning models on top of already trained models. I hope you enjoyed our presentation today, and I hope you learned a lot about GeoAI and deep learning. I'm looking forward for your questions and looking forward to work with all of you in order to deploy deep learning within your day-to-day workflows. Thank you.